You're on.
Okay. All right, everyone. Thanks for coming. We're going to be talking about fire dampers today. Just a quick introduction. I'm TJ Zinn with Aire Technologies. I'm the engineered sales manager. I've been with Aire Technologies for 4 or 5 years now. I have a background in mechanical engineering, and I've been translating that into the testing and the product management and the sales engineering for Aire Technologies. So my primary role with the company is to call on mechanical engineers and get our products specified and see if we do meet specifications. And if we don't, figure out how to make it so that we do meet specifications. So we'll be talking a little bit about, I'm not going to go into the history of ATI today or anything like that. What I will drill down on is fire dampers and the standards that they meet, the applications, the differences between, say, fire dampers and ceiling radiation dampers, and some of the other confusing verbiage that we tend to see in the industry. So that being said, we'll be starting off with kind of going over what you see on the second line down. So the top line is our louver line. Second line is our fire dampers. These are all of the series of different fire dampers that we offer. And what I'll be going over today is how to define which one the customer needs for the specific application. So that being said, the easiest way for us to communicate this and make sure that we get the correct damper for the application is to go through each of these questions on our product survey. This product survey, we try to supply as often as possible to the customers when we're going through the quotation process to make sure that we have the right damper for the job. So these 11 questions will give us everything that we need to know in order to build the correct product. That being said, not all of these 11 questions always are known or need to be known in order for us to quote. We can kind of defer to the worst case scenario sometimes, and there's advantages and disadvantages with that I'll be covering so that everybody knows what's kind of flexible as far as the spec goes and what might not be flexible. So I'd like to start off talking about the purpose of a fire damper, defining it, what is it, and what does it do? A fire damper is intended to limit the passage of flame through a fire-rated assembly. So be it a wall or a floor ceiling assembly or a fire-rated partition or barrier of some sort, if you have ductwork running through a fire-rated wall, then you're running basically a 26 gauge, 28 gauge duct through a firewall that could be rated up to 3, 4 hours, 5 hours. Obviously, that is an opening in the assembly, in the fire-rated assembly, that would allow fire and heat to pass through. So the purpose of the fire damper is to remain open normally, and then when it detects a certain amount of heat, it'll close off the partition, sealing off that partition and preventing the flame from spreading from unit to unit, say in a multifamily job, or from office to office in a mixed-use building. Fire dampers, again, are intended to limit the passage of flames through a rated assembly. This is different from ceiling radiation dampers, and there's a lot of confusion between the two. In order for us to really define and quote a fire damper, we need to know these 3 primary characteristics about the damper. That's the attitude, the system type, and the fire rating. The attitude is defined as vertical or horizontal, so I'll get into that on the next slide. The system type being static or dynamic, and then the fire rating being 1.5 hours or 3 hours. So while we do have 11 questions on the product survey, these 3 are the life safety critical questions that, in my opinion, don't have any flexibility when it comes to speccing the right product. So looking at, actually, I'm going to start with number 2 on our product survey, which is the first question on the previous slide. Are these vertical or horizontal fire dampers? What you see in front of you on this screen is the application of a vertical fire damper. The wall is a vertical fire barrier, so the fire damper is going to be reestablishing that vertical fire barrier, hence a vertical fire damper. Here, however, you have a horizontal fire damper. Even though the ductwork runs vertically, the fire-rated partition is in the horizontal plane, so the damper is going to reestablish that horizontal plane, hence a horizontal fire damper. So the question here on our product survey is, are these dampers going to be installed in ducts where they penetrate a wall or a floor? And that's something that we need to know. The difference between the two in terms of construction really comes down to the spring being the primary difference. And it's not always the biggest difference, but in most cases it is. So here, for example, the vertical fire damper you can see on the left-hand side, there's no spring, it's just drawn closed by gravity. What you can't really see in the picture is a fusible link. A fusible link is two pieces of brass held together with a heat-sensitive solder. It melts upon a certain temperature, so 165 degrees Fahrenheit or 212 degrees Fahrenheit. Once it reaches that certain temperature, the two pieces will slide apart and the damper blades will draw closed like a curtain. So on the left-hand side, again, you've got a vertical fire damper, no spring, it just gravity drops. On the right-hand side, you've got a horizontal fire damper that actually needs a stainless steel negator spring in order to close the damper and keep it closed. What you also see there highlighted in yellow, and I don't know if you can see my mouse here, but if you can, you see highlighted in yellow this blade lock. So basically this negator spring right here draws the blade stack closed and the blade lock holds them closed in the event of a fire. So here's kind of a side view drawing, profile drawing of the two types of fire dampers. On the left, you have a vertical mount. On the right, you have a horizontal mount. So you can see the negator spring right here. What you don't really see too well is the blade lock. Whereas on the left, there's no spring, there's no blade lock. It's just dropped closed by gravity with these interlocking curtain style blades. So what I'd like to point out here is kind of the different standards that these come down to. And this doesn't really have much to do with kind of the day-to-day conversation with the distributors or contractors or anything like that. But when it comes to fire dampers meet the UL 555 standard. They're often confused with ceiling radiation dampers. So one of the first questions, or one of the most common questions I'm ever asked is, hey, I need a ceiling fire damper, or I need a fire damper. And I don't know if they are looking for a ceiling radiation damper or if they're looking for a fire damper, because that term is used so arbitrarily in all cases. So there is a distinction here. Ceiling radiation dampers meet a different standard entirely. They meet UL 555C. That is where you have a membrane penetration of a floor ceiling or roof ceiling assembly. So that is not what we're talking about here. What we're talking about is fire dampers, which are for through penetrations of the entire floor ceiling assembly. That means the duct is breaking the ceiling line and then also breaking the floor line above that. Fire dampers not meeting the temperature limitation of ceiling radiation dampers shall not be used as a substitute. So what I see a lot of the times is they'll take, we have different parties, engineers specifying these to contractors using these, to inspectors requiring these. A fire damper cannot be used as a ceiling radiation damper. So when we're talking about the vertical versus horizontal, a horizontal fire damper is what I see in most of these cases. They'll put it in the ceiling line. That's different entirely from a ceiling radiation damper. But without getting too far off track, I just wanted to bring that note up while we were talking about the vertical versus the horizontal application. So the first question on our product survey and the second question in the slide beforehand is the static versus dynamic spec for a fire damper. Fire dampers are classified into either static systems or dynamic systems. A static system is a system in which the air handler is shut off in the event of a fire. A dynamic system is a system in which the air handlers continue to run in the event of a fire. So what's the difference there in construction? Well, it comes down to the construction of the fire damper and the application of the spring. I mentioned a little bit earlier that in general, vertical fire dampers won't have springs attached to them. I kind of lied a little bit. Sometimes they do. Sometimes they do if it's a dynamic system. So here you see two different profile drawings. On the left-hand side, you see a vertical dynamic fire damper. What's different between the two is that spring and the blade lock that you saw earlier on the horizontal fire dampers. So the spring is going to draw the blade stack closed. The blade lock is going to hold those blades in place so that in the event of a fire in a dynamic system, the fans are continuing to run. They don't blow the fire damper back open and allow flame to pass through them. On the right-hand side, though, you have a static vertical fire damper. So there's no moving air. It doesn't need to keep closed against anything. And the blades aren't going to magically pop back open, so we don't need the negator spring and we don't need the blade lock. So all that to say, so far we've covered the system type, static versus dynamic, the attitude, which is the horizontal versus vertical. And now we'll get into the hourly ratings. Third question on the survey is, what is the fire rating of the partition? According to IBC, there are 2 classifications for the hourly rating of a fire damper. That is 1.5 hours, and those are to be installed in any partition, any assembly that's rated less than 3 hours. If you have a 2-hour firewall, then you need 1.5 hour fire damper. If you have a 1-hour firewall, you need 1.5 hour fire damper. But when you get to 3 hours, that's when you need the 3-hour fire damper. They're tested to different standards or different lengths of time to the same standard, the UL 555. So again, coming down to it, those are the 3 questions that we need to know: attitude, system type, fire rating. In addition, we talked a little bit about, okay, what sets Aire Technologies apart with our dampers? You know, a fire damper is a fire damper is a fire damper. But what we do is we have multiple different versions of fire dampers in order to accommodate different applications that may or may not have been known at the beginning of the testing, but they're versatile products. The biggest difference in classification is the standard versus the thin line profile. What you have is a standard profile is about 4¼ inch thick. And that's what you'll see on our Series 75, our 05, our 77, our 99. But then we have a thin line profile fire damper, again, curtain style, Series 65 and 95, and I believe 61 as well. And that actually should say, I think, 61 instead. But the 61 and the 95 are both 2-inch profile thicknesses, so that if you have a thin wall, a 2x4 wall or something like that that's rated to a certain fire rating, that's when these come into play. The fire damper needs to stay in that partition, and this allows a little more flexibility for the contractor installing them. Fire dampers, and so moving on away from some of the life safety specific portions of fire dampers, you've got the orientation of the blade stack. Ultimately, when you're talking about fire dampers, the life safety portion doesn't really care if there is a pressure drop across the damper. Who does care is everybody else involved with the system that's designing it to certain pressure ratings or certain performance standards. So that's why we have different orientations of the blade stack. A type A fire damper has the entire appliance inside of the airstream. So if your ductwork is running through a wall, you install your fire damper in the sleeve, you install the sleeve around the outside perimeter of the fire damper, and then that blade stack's going to take up room, the frame's going to take up room, anything else involved with the damper is also going to take up room. These tend to be the most kind of go-to, the standard go-to, a type A fire damper, but because they're a little less expensive, they're a little less material intensive, but they do have a pressure drop across them. A type B fire damper has the blades elevated above the airstream. So your blade stack is going to be above the ductwork. Your ductwork is going to make its connection at this hi-hat right here. And everything's outside of the airstream. So you don't have that pressure drop. And imagine, obviously here, we're talking this, what looks like 1 inch or 2. But the bigger and bigger and bigger these fire dampers get, the bigger that blade stack gets and the more percentage of the airstream it takes up. And then type C is for round. Basically, we install a round collar on the fire dampers to accommodate round piping or round flex duct or whatever. One thing that Aire Technologies does really well that sets us apart from some of our competitors is the way that we vet some of these requests. So again, you'll get a lot of questions, a lot of the back and forth that we're trying to eliminate. One of the questions that we tend to go back and forth about is it pertains to the type C fire damper. When a type C is sold without a sleeve, it's sold just like this. The problem though is that you have to install fire dampers and sleeves, which I'll get to in a later slide. When you install this fire damper in a sleeve, it makes it extremely difficult to reach that collar to make that duct connection to the rest of your system. So one of the things that our technical sales department and everybody on the team tries to vet is if you're requesting a type C or even a type B fire damper, we always try to make sure that you get the sleeve from us from the factory so that ultimately the end user is not in the field trying to figure out, well, how do I put this together if the collar is all the way inside of the sleeve and I can't reach it. So to illustrate, we'll get to that in a little bit. I mentioned earlier that these are actuated by fusible links. Fusible links meet a certain temperature tolerance requirement of 165 degrees or 212 degrees. The reason that there are two different temperature requirements are for the ambient temperature ratings. If you're thinking about installing a project in, I mean, I know you guys don't go too far south, but let's say it's in the middle of summer, you're installing one in Harrisburg, Pennsylvania, and they're stuck in a job trailer and it's pretty hot out. Well, odds are that this job trailer or even an unconditioned attic space is going to reach above 100 degrees Fahrenheit. In that case, it's going to slowly erode at that 165 degree link. And then you're going to end up with having a bunch of fusible links that have popped, the dampers are closed, and the system's not performing. So to mitigate that, we highly recommend going with the 212 degree fusible link, as it's a higher ambient temperature rating and it's less susceptible to closing early. Difference here is our 165 degree link is standard. That's only because we tend to try to match what is the industry standard for the sprinkler system, which tends to be 165 degrees. So we try to match that. That's just always been our standard, and we're happy to accommodate the 212 degree link as well. There are some cases where you might need a stainless steel fire damper. All of our fire dampers, for the most part, are galvanized steel, but we also offer stainless steel fire dampers as well for high humidity applications. If you've got an indoor pool or some kind of sauna or anything that has a fire rated damper that is going to be susceptible to high humidity or highly corrosive elements, then we recommend going with our stainless steel fire damper. I'm going to go ahead and skip over this to get to the factory installed sleeves. Now, I mentioned earlier that all fire dampers need to be installed in sleeves. And when I was talking about the type C and the type B fire damper, I was talking about how difficult it can be to install the damper in the sleeve and connect it to the rest of the ductwork. This is a SMACNA standard, and it's typical building construction for all fire dampers, regardless of the manufacturer. A fire damper gets installed in a sleeve. The sleeve connects to the rest of the ductwork to establish a breakaway connection. And what is a breakaway connection? I'll get to after this slide. I mentioned earlier that fire dampers in sleeves are installed to the assembly with retaining angle. Retaining angle just being the L bracket that sandwiches the damper into the plane of the wall, sandwiches the wall more or less, and keeps the damper in place. So this is a breakaway connection here. The sleeve, the retaining angle, and the damper all work together to form that breakaway connection. The damper itself is in line with the wall. You've got your sleeve extending on either sides of the wall, and then your sleeve connects to the rest of the ductwork using that breakaway connection. So to illustrate, let's pretend for a moment that this is a 3-hour rated firewall. We need to run our ductwork through this 3-hour rated firewall. So to do so, we have to reestablish the fire rating of the barrier in the event of a fire using a fire damper. This fire damper is installed in the sleeve. The sleeve is held in place with retaining angle. One advantage that Aire Technologies has is that we can use either double-sided or single-sided retaining angles for fire dampers that are 36 by 36 and smaller, which I'll get to in a minute. But typically what you have is your angle, shown here in white, is screwed into the sleeve, with screws shown here in blue, and it sandwiches the wall in between the two sets of retaining angles so that the damper doesn't slide laterally. You also see here a little bit of an expansion gap that's intentional, that's supposed to be to allow for thermal expansion. So here you have your flange on the ductwork, a neoprene gasket in between the two flanges, and a PVC cleat or a steel cleat in some cases that holds that subassembly together. So that in the event of a fire, you've got your dynamic system. The fans are continuing to run, so the air is pushing against the fire damper. You've got a 3-hour rated wall. If the 1-hour floor ceiling assembly collapses on one side of the wall, it doesn't rip the damper out of the plane of the wall. The damper stays in place. So I want to pause here and take a moment and say, If you have a type C or a type B fire damper, typically what you'll see is your hi-hat will extend right here, but you can see that your sleeve goes out farther. So you've got to make this duct connection to this hi-hat or this collar that ends right here. And you've got a very little space to work with, which is why we always recommend, if you're getting a type B or a type C damper, always get the sleeve installed.
So TJ,
yeah.
On that note, what do you see most common for the Northeast US right now as far as requests coming? Besides, obviously, I know what we would recommend, but just what are you normally seeing on this type of?
I would say it's a mix of type A and type B. I'd say most common is probably type A. I'd say if I had to break it down, it would be like a 50% type A, 40% type B, 10% type C kind of deal.
And we're usually trying to push people one direction, or if it's already spec'd as an A, B, or C, we don't really get to change.
Typically, the engineering specs will say type B, but the reason I say that type A is more popular is because that tends to be the kind of the contractor's choice. In most cases, sometimes the specs will say type A. So you'll see a lot of type B spec on the plans. We always recommend type B. Where you'll see kind of a disparity is if we're quoting type B and another manufacturer is quoting type A. Well, there's going to be a little bit of a disparity, but if we're meeting spec, then we're meeting spec and they're not. We need to keep that in mind. So I would always recommend go with type B in a sleeve, and that's going to get you the better system performance. I mentioned earlier that Aire Technologies offers the option to have single-sided retaining angle for the fire dampers up to 36 inches by 36 inches, which probably comprises about 80% of the fire dampers that we manufacture. The advantage here is, there's a lot of advantages to having a single-sided retaining angle. Ultimately, it comes down to the fact that you're installing one angle instead of two. So you're seeing a significant time savings. You're also seeing a significant material savings. And this has been tested at UL, so this is a UL approved installation method. If you've got if this side of the wall is inaccessible and you cannot install a retaining angle on here, this allows for that flexibility. Here we have a video of the retaining angle test at UL. I don't know how we're doing on time, so I might actually defer to skip over this, but Scott, how are we doing on time?
I think you're fine on time. You could take the full hour if you wanted to.
Yeah.
Okay. All right. So hopefully this comes through on the recording. I'm not sure if it will, but we'll try it.
5, 4, 3, 2, 1.
I feel like there's a lot we can take away from this video for like real world application for people like me who imagine what's going on. Mm-hmm. So I don't know how well I'm doing on interrupting, TJ, and I apologize, but did you see how much airspace that blade stack took up when it was coiled at the top, if he rewinds a little bit? And so that everyone, like, look at that. So let's say that's what is that, a 60 by 60 damper, TJ?
I think it's 36, 36.
That must be at least 6 inches a stack.
Okay, so 36 by 36. And that's going to be a question I want to follow up with our team on if TJ's not covering it. But like, I want to know if you guys know how big that stack is based on the size, because we have a tool to figure it out. But that takes up a lot of airflow, because like what TJ is saying, if TJ mouses over the corner, that's the connection. So what you're looking at is the part that's installed in the wall there. The part that came off, that's the sleeve and the angle. So like that's to simulate like a burning room and the floor dropping down and like hitting that sleeve, and the damper needs to stay. It's hitting the ductwork, right? And that's the reason for the breakaway connection. So the damper stays in the wall and closes and it maintains the integrity. And so this is just, a lot of times we're holding the samples and it's pretty small, but the bigger the damper, the bigger the blade stack, right? And you can imagine, you know, the force that some of these things close with if they're spring loaded too. So go ahead, TJ, sorry to interrupt.
Yeah, I mean, that's actually a really great point. So thanks for bringing that up. And we do have a chart in some of our, and we have a PDF that we can send you as well that shows, okay, the bigger the damper, the bigger the blade stack, meaning the bigger the pressure drop more or less across the damper, not exactly a 1-to-1 ratio, but you get the idea. Here you can see the neoprene gasket. You got the corners. You got you might have seen during the video some cleats just flying off, and those were PVC cleats that went flying when you drop the barrel on top of the ductwork. And right here you can see this is the flange, the corners, the angle right here.
5, 4.
Now we do the same thing for our combination fire smokes.
1.
And so this is for the combination fire smokes, which is a little bit outside of the scope of this discussion. So I'm not going to go too far into that, but same idea. We're testing a single-sided retaining angle here. And so in order to pass the test, we had to install, you can see the screws on both the wall going into the wall and also into the sleeve on the one side of the damper. And there's no angles on the other side of the damper. So as you saw, I don't, if you noticed on the previous slide, there were a whole bunch of people walking around. One of those individuals was our UL representative watching and witnessing the test and documenting the performance of the damper after the drop test. If the damper racked at all, then we wouldn't have been able to do the single-sided retaining angle. We test all of our products with UL. So whenever we have any new product or any augmentation to the products, we always do this at UL or at Ohio Independent Laboratories with UL witnessing it. In this case, UL for fire dampers always requires that we test the largest size of the fire damper that we offer. If we want to offer a 10-foot by 10-foot, then we have to test a 10-foot by 10-foot. So here you can see on the left-hand side, the fire damper is installed on a wall that rolls on, or on the right-hand side, I'm sorry. This is a gigantic roller, and so they bring it over to the face of a furnace and it latches onto the face of a furnace. This picture right here is the damper latched onto that face of the furnace. All these spikes here are thermocouples that read the temperature distribution throughout the furnace, and then these 6 holes are, I guess 9 actually, blow heated air into the furnace to heat up the dampers and so that they will close. Furnace gets up to about 1750 degrees Fahrenheit during the test, and they test for both mechanical and thermal failure criteria. This is the damper in the middle of the UL testing. So you can see there's a significant amount of deflection there. One thing that I like to always address when bringing up this picture is that the thermal expansion that I showed on the previous couple of slides ago when I was talking about the breakaway connection, there is an 1/8 inch per linear foot of damper space that's just open around the damper. And intuitively, you might think, well, if you're leaving a gap around the damper, it's going to allow more heat to come through. Yes, but in this case, you can see at the apex of the temperature at the UL fire test, this damper expands a significant amount, so much so that it actually deflects in the center because it's got nowhere else to go. And this originally caused us to fail the test when we tested it for the first time. So you can see the damper is red hot. I did not witness this testing, but I did witness other testing with a combination fire smoke damper. The room was just uncomfortably hot on the other side of the damper. The damper is just working to its maximum limit to prevent that flame and that heat from coming through.
I wanted to say something about that picture, and even these pictures too are fine. And maybe you said it, TJ, but I didn't hear you. So when we test to the max size that we want to be able to produce, that doesn't always mean that it's a single section size. So in this case, it's probably is it a 120 by 120? made up of 460 by 60. So what you're looking at are 4 dampers, 2 on the bottom and 2 on the top, to make a 120 by 120. So when you look at our spec sheets or someone's asking for a size, it's important that we know the limitation, because like we have competitors that just do whatever. I'd like 1,000 by 1,000 damper. Okay. So, you know, and somebody's going to go, okay, fine. You can put together like 10 120 by 120s, but there's going to be a limit on the single section size. And there's also going to be limits on how many you can put together too. Do you want to touch any more on that, TJ?
I think that's actually a really good question, because I get this question fairly frequently. Hey, I see your maximum size for, let's say, for dynamic dampers. Dynamic dampers, they have a slightly more limited size offering. I want to say 36 inches by 36 inches. So the question I'll get is, well, can I just stack a bunch of them together? And the answer is no, because we did not test all of those together. The more you remove from the wall, the higher the likelihood is that flame is going to pass through. So unless we test them all together, then we need to limit ourselves to what's safe for the application. So here, you're exactly right, Jennifer, and thanks for bringing that up. We originally tested 4 sections, each 60 by 60, and so it had to meet thermal criteria and mechanical criteria to pass. So I think that's a really good point. It's something that we try to be sticklers about. Again, we try to make sure that we head off all of the problems that we can on the front end, so that we're not stuck dealing with this on the back end, causing more cost and time and wasting everybody's resources trying to fix a problem that should have been prevented from the very beginning.
And the other thing is not only fixing the resources, but like TJ said, the bigger the hole, the more likely that fire is going to get through. I mean, a good scenario is the inspector catches it and we don't have a product installed that doesn't perform. In the bad scenario, a building catches fire and people die because the damper fails and stuff like that. So, I mean, it is really serious to make sure that people are installing this stuff within the scope of what we're tested to do.
Right. Absolutely. Absolutely. And it's not just a commodity. It's something that we pay a lot of attention to and pay a lot to make sure that standards are met. This, I think, speaks a lot to the quality of Aire Technologies, to show that this one in particular, it did fail the test. So we ended up going back and retesting it with 6 sections for this size. But what it does show is the quality of the damper was able to prevent flame from passing through a 10-foot by 10-foot area. And that's a pretty substantial size. I don't know too many projects that have duct sizes that are greater than 10-foot by 10-foot. So here we have kind of a little bit out of order, and I probably should rearrange some of these pictures, but on the bottom left, you can see stage 1, you set up the damper over the face of the furnace. Step 2, the fire test begins. Obviously that guy who's down there, he's out of there by that point, and the dampers close. And then step, they should be flipped again. So I have step 2 and step 3 swapped. Step 1, bottom left. Step 2, top right. The flames start, the damper's still open, and then it closes. And then on the top left, you see the damper's closed, it's heated up, it's preventing flame from passing through. After the fire test, we also spray it with a fire hose at 45 PSI for about 90 seconds, give or take, depending on the test. This is to simulate, obviously, firefighters coming in, they spray the damper. If there's still flame on the other side of the damper, you don't want the damper to fail. And then while the firefighters are in there trying to bring people out or save anything, it needs to withstand this fire hose to maintain its structural integrity. So what you see on the right-hand side, I mentioned earlier that we originally failed this test. We did not pass this test the first time we tested, so we had to go back and change a few things about our design until we passed. What you see on the right-hand side is the railing. It's like a railing slash a floor yellow marker on the floor above the test, and those 2 blades popped out entirely, and that would have failed the test. So it did survive the fire portion. It did not survive the fire hose portion. Like I said, we went back, we retested, we changed the design, and now we're using the new design that is robust and very solid. So these ones I wanted to throw in here. Again, I'm getting really into the weeds on some of the fire damper code specific stuff. So this is the kind of stuff that I see this come up often enough that I'd like to make sure that you guys are equipped to understand what to do in these situations. I mentioned earlier the difference between a fire damper and a ceiling radiation damper. Fire damper is for through penetrations. A ceiling radiation damper is for membrane penetrations. So here in this illustration, this is directly from the NFPA 90A, which is an awesome resource. If you have it, I would recommend keeping it around just to reference. So what you see here is, and I'll try to find all of these FDs. That means a fire damper, fire damper, fire damper, fire damper, fire damper. And right here, you see a horizontal fire damper. If you can see my mouse, this horizontal fire damper is sealing off this horizontal fire rated partition, whereas this one is sealing off the vertical fire rated partition. So is this one. All of these, with the exception of these two scenarios, which are, I don't need to get into those at the moment. It's a very, very specific niche scenario that you might not need a fire damper, but in most cases you do. Here's an illustration I actually received from an architect in Dallas, Texas, D2 Architecture. A gentleman's name is Brandon Kreiner. He is very knowledgeable about ceiling radiation dampers and fire dampers and everything. And so what he wanted to do was just to draw up a reference sheet that he could use for certain projects. And so what he did was he said, okay, in this case, if I've got a duct and a rated shaft partition, I need a fire smoke damper. If I've got a fire damper in a breaking through a fire partition, well, I need a fire damper. If I've got my duct running up through a horizontal assembly, but it stays within the bounds of the horizontal assembly. So if this is the top, this is where you see a ceiling radiation damper, and here and here. And so there's different scenarios where this is not to be confused with a horizontal through penetration, because what you can't really see here is the top of that roof assembly. It's not going all the way up through the assembly. It's just breaking the membrane of it and then running within that space. Ultimately, all of these specifications come down to building codes. So we're talking about life safety dampers. It's all deferred in the IBC, the International Building Code, as well as the International Mechanical Code, International Fire Code, and whatever relevant local jurisdiction would require. And I've got all of these outlined, and I'm happy to share it with you as well. So as far as the PowerPoint portion of this presentation, that's all I've got. And I'm happy to talk about other questions related to fire dampers, related to the specs you need to know. Before we go into like a Q&A real quick, I did just want to jump back to my product survey and address these questions. So again, the whole purpose of this was to say, look, we've got 11 questions on our product survey that we need to know in order to quote you. Did we answer all of those? So the first one being, is it a static or dynamic system? We addressed that. Static systems shut down the fans, dynamic systems don't. Are these horizontal or vertical fire dampers? Well, we answered that one. What is a fire rating? That addresses the hourly fire rating of the fire damper, either being an hour and a half or 3 hours. Are there dimensional restrictions in the partition that might impact the profile of the damper frame? That's addressing, is it thin line or is it standard profile? Now we're moving off of the life safety damper portion, the life safety portion. What are the duct dimensions? We need to know that in order to quote them. It's often harder than it should be, I think, to get that question answered. The damper blades are to be in the airstream or out of the airstream, type A or type B. The whole appliance and frame are to be out of the airstream, which is 100% free area. So if it's yes, then that's a type C. What fusible link temperature is required? Again, 165 is standard, 212 is optional, no cost difference. Are there requirements for a product manufactured in stainless steel? Yes or no? Will sleeves be factory or field installed? We always recommend factory installed. If it's factory installed, what length of the sleeve do you need, and then do you want us to supply the retaining angle, or are they going to supply it in the field? One thing that, again, to keep in mind, every fire damper needs retaining angles and sleeves and access doors. So if you get a request for fire damper, keep in mind, do you need sleeves? Do you need retaining angles? And then do you need access doors?
Great, thank you, TJ. Scott, I think we can probably stop the recording now.
Great presentation, TJ. Yep, we're stopping recording
Okay.
now.